All right, so let's go ahead and look at attributes of logarithmic functions. What we are going to do is we're going to compare and kind of go back and forth, like converting exponential functions to logarithms and vice versa. Okay, so this does heavily depend upon that reverse Hart method that we were talking about in videos before. And the fact of if we had something that looked like log base A of B is equal to C, that we would start from the base and we would do this reverse Hart method and write converting it to an exponential function, which would be a to the power of c is equal to b. Okay, so I took this logarithmic function and I converted it over to exponential with this reverse Hart method. And yes, to go back and forth, let's say that I have an exponential function and I'm going here. The biggest thing to do is understand that you're going to have some log base of something, of some argument, and it's equal to some number. And I would say the best way, if you're going from exponential to logarithm, is to still keep in mind that that base is very important, and you know that it's going to go there as far as the base for the log. And then since it's saying it's to the power of c in an exponential form, you know reverse Hart method, then this c is going to have to go over here because it's just going back and forth between rewriting it. And then last but not least would equal b. If you're, again, going from exponential to logarithmic form, you know that you have to complete that reverse Hart method by knowing that the b is going to go here. So again, here's your a raised to the power of c is equal to b. And again, these values, a, b, and c, they're going to be constants. Some of them are going to be constants. Some of them are going to be variables. So chances are is that you're going to probably have two of these, and then you're going to have one that's an unknown, which means that you would have to set it up in order to solve for that unknown. You may know a and b, solving for c. You may be given a and c, solving for b, which is your unknown, or you might have b and c, where you're solving for a, and x being that unknown variable that you're solving for. Okay, so let's go ahead and go to our example A here. It says, what is a logarithmic form for the equation? So we have an exponential form and a logarithmic form. We're basically going to go from exponential to logarithm over here that we started off our examples with. So I'm going to concentrate on this 10 base. So it's log base 10. And then I'm going to secondly concentrate on this 2 because it's raised to the power of 2. Okay. And then last but not least is going to equal 100. Whoa, is going to equal 100. So I'm going to write, get that smaller. It's going to equal 100, meaning the second part of that reverse Hart method would be the 100 is that argument. Okay. So again, 10 raised to the power of 2 is completed here. And then whenever you say is equal to 100, that would be completed here. Okay, so what did I do just now? I just converted this exponential given example right here in exponential form. I converted it to logarithmic form. Okay. All right, so that's why you see, as far as the rewrites, logarithm is this exponential, and this logarithm with variables is this exponential equivalent. All right, so let's go to B. I have 3 raised to the power of 4, so I'm already thinking log base 3 with the 4 way over here because it's the reverse Hart method, and then is equal to 81. That means is equal to 81. So that my answer is going to be log base 3 of 81 is equal to 4. This is the logarithmic equivalent of this exponential given. Let's look at problem 2. Problem 2 says, what is the value of log base 8 of 32? So again, sometimes and very, very often we'll be given something that looks like this, and it's asking us, what does this equal? And you could put question mark or you can put X. Okay, since we're used to putting X for things that we're solving for, okay, so we're used to being asked to solve for X, like an example like this, You could say that, well, if I don't know what log base 8 of 32 is equal to, well, let's set it equal to x. And again, I'm given a logarithmic form. So the best way to solve this, unknown is to convert or rewrite this logarithmic form into an exponential form. Okay, so I'm going to rewrite this as an exponential with the reverse Hart method. 8 to the power of x is equal to 32. That's how I rewrite it. First, with the 8 to the power of x, let me go ahead and write that down here, is equal to 32. Now, this one's a little bit different because if x is 1, okay, then I know it's 8. But if x was 2, then it'd be 64. If x was 3, it would just keep going because you're multiplying by 8, which would be what? 212. Because 64 times 8 would give you that 212. Let me make sure on that. So 8 to the power of 3, 512. What am I doing? So 512, because it would be the 48 plus the 3. Okay? And with that being said, we are given multiple choice, but let's say we weren't given multiple choice and we were asked to find still what did this log base 8 of 32 equal by doing this by hand. Okay, so if you were given log base 38 of 32 and we wanted to find it without multiple choice, let's say these were not there at all, this is how we would do this problem. We would try to find common bases that exist amongst the base here on the left side of 8 and the base here, or this number here, of 32. So watch what we're going to do. This 8 is going to turn into 2 cubed. Okay? That means this x out here is still going to be written right here. And now 32 is 2 to the power of 5. Okay? So with that being said, we've learned in previous units that a power raised to a power right here, we're going to multiply. And then here I have a 5. So because of the fact that these two bases are the same values, they become negligible. Like I don't even have to look at them. The only thing that I have to set equal to each other from now to solve it are the powers. Since the bases are the same, they're not important anymore. I have to make them the same first, but then they don't become important because the only things that's going to set this equation equal, the left side equal to the right side, is if and only if these powers are actually equal. Okay? We know a power raised to a power we multiply, we get 3x, and then this power is just 5, and now I can just simply solve by basic algebra of dividing by 3, and you would get 5/3. Okay? So now let's go ahead and find quickly this equivalent logarithmic form. We have the base is 6, so it's log base 6. It's raised to the power of 2, so the 2 is going to go way out here because of that reverse Hart method. Okay? And then it's equal to 36, so 36 would be the argument. Again, the base, the argument, and then the number over here. We're in exponential form, it's the base, the power, and then the number that it's equal to over here. Okay? All right, so let's keep going and go to and finish up with problem 2. I believe that is it. We don't have, yep, that's it, just problem 2. All right, so it says, what is the value of log base 5 of 125? Again, this is coded and it represents a number. We just have to figure out what number does this represent, okay? Now, I'll quickly show you just for practice in the calculator, this button right here, look for log, and the base is 5, and the argument is 125. The answer should be 3. And the way you solve that out is you're going to set it equal to an unknown variable. You could even put question mark if you wanted to. Remember, we've been putting x, you could put question mark. Because reverse Hart method, again, we are given logarithmic. So the best thing to do is to rewrite it in exponential form starting from the base. Reverse Hart method says it would be 5 raised to the power of question mark is equal to 125. Now, 5 raised to what power would be 125? that question mark is 3 because 5 cubed is 125. 5 cubed is 5 times 5 times 5, which is 25 times 5, which of course is 125. And that's how you convert back and forth between exponential functions and logarithmic functions, okay? So there's the work right there. My apologies for not changing that back, but I'll go ahead and highlight it. It's 5 raised to the power of question mark, which I wrote right here, and then is equal to that 125 argument piece. And like I said from before, 5 raised to the power of something is 125. That something up here has to be 3 because 5 cubed is 5 times 5 times 5, which checks out to 125.